Hello, welcome back. Let's start the reading. It's soon 12. I like to read about this nice old fighter jet. So I need a minute to get to my bed.
Panavia Tornado. The Panavia Tornado is a family of twin-engine, variable sweep-wing multi-role combat aircraft, jointly developed and manufactured by Italy, the United Kingdom and Germany. There are three primary Tornado variants: the Tornado IDs, interdictor forward/strike, fighter bomber; the Tornado ECR, electronic combat forward/reconnaissance, SEAD aircraft; and the Tornado ADV, air defense variant, interceptor aircraft. The Tornado was developed and built by Panavia Aircraft GmbH, a trinational consortium consisting of British Aerospace, previously British Aircraft Corporation, MBB of West Germany, and Air Italia of Italy. It first flew on the 14th of August, 1974 and was introduced into service in 1979-1980. Due to its multi-role design, it was able to replace several different fleets of aircraft in the adopting air forces. The Royal Saudi Air Force, ASIF, became the only export operator of the Tornado, in addition to the three original partner nations. A trination training and evaluation unit operating from RAF Cottesmore, the Trinational Tornado Training Establishment, maintained a level of international cooperation beyond the production stage. The Tornado was operated by the Royal Air Force, RAF, Italian Air Force, and ASIF during the Gulf War of 1991, in which the Tornado conducted many low-altitude penetrating strike missions. The Tornadoes of various services were also used in the Bosnian War, Kosovo War, Iraq War, in Libya during the 2011 Libyan Civil War, as well as smaller roles in Afghanistan, Yemen, and Syria. Including all variants, 990 aircraft were built. Development, edit. Origins, edit. During the 1960s, aeronautical designers looked to variable geometry wing designs to gain the maneuverability and efficient cruise of straight wings with the speed of swept wing designs. The United Kingdom had cancelled the procurement of the TSR-2 and subsequent F-111K aircraft, and was still looking for a replacement for its Avro Vulcan and Blackburn Buccaneer strike aircraft. Britain and France had initiated the back-forward/Dassault AFVG, Anglo-French Variable Geometry, project in 1965, but this had ended with French withdrawal in 1967. Britain continued to develop a variable geometry aircraft similar to the proposed AFVG, and sought new partners to achieve this. West Germany WR with Boeing, then with Fairchild Hiller and Republic Aviation, had been developing design studies of the swing-wing EWR Fairchild Hiller a 400 AVS Advanced Vertical Strike, which has a similar configuration to the Tornado, from 1964 to 1968. In 1968, West Germany, the Netherlands, Belgium, Italy and Canada formed a working group to examine replacements for the Lockheed F-104 Starfighter, initially called the Multi-Role Aircraft, MRA, later renamed as the Multi-Role Combat Aircraft, MRCA. As the partner nations' requirements were so diverse, it was decided to develop a single aircraft that could perform a variety of missions that were previously undertaken by a fleet of different aircraft. Britain joined the MRCA group in 1968, represented by Air Vice Marshal Michael Giddings, and a memorandum of agreement was drafted between Britain, West Germany, and Italy in May 1969. By the end of 1968, the prospective purchases from the 6 countries amounted to 1,500 aircraft. Canada and Belgium had departed before any long-term commitments had been made to the program. Canada had found the project politically unpalatable. There was a perception in political circles that much of the manufacturing and specifications were focused on Western Europe. France had made a favorable offer to Belgium on the Dassault Mirage 5. Panavia Aircraft GmbH, edit. Main article, Panavia Aircraft GmbH. On the 26th of March, 1969, 4 partner nations, United Kingdom, Germany, Italy and the Netherlands, agreed to form a multinational company, Panavia Aircraft GmbH, to develop and manufacture the MRCA. The project's aim was to produce an aircraft capable of undertaking missions in the tactical strike, reconnaissance, air defense, and maritime roles. Various concepts, including alternative fixed-wing and single-engine designs, were studied while defining the aircraft. The Netherlands pulled out of the project in 1970, citing that the aircraft was too complicated and technical for the NLAF's preferences, which had sought a simpler aircraft with outstanding maneuverability. An additional blow was struck when the German requirement reduced from an initial 600 aircraft to 324 in 1972. It has been suggested that Germany deliberately placed an unrealistically high initial order to secure the company headquarters and initial test flight in Germany rather than the UK, to have a bigger design influence. When the agreement was finalized, the United Kingdom and West Germany each had a 42.5% stake of the workload, with the remaining 15% going to Italy. This division of the production work was heavily influenced by international political bargaining. The front fuselage and tail assembly was assigned to BAC, now BAE Systems, in the United Kingdom, the center fuselage to MBB, now part of Airbus, in West Germany, and the wings to Air Italia, now Leonardo, in Italy. Similarly, trinational work sharing was used for engines and equipment. A separate multinational company, Turbo Union, was formed in June 1970 to develop and build the RB199 engines for the aircraft, with ownership split 40% Rolls-Royce, 40% MTU, and 20% Fiat. At the conclusion of the project definition phase in May 1970, the concepts were reduced to 2 designs, a single-seat Panavia 100 which West Germany initially preferred, and the twin-seat Panavia 200 which the RAF preferred. The aircraft was briefly called the Panavia Panther, and the project soon coalesced towards the 2-seat option. In September 1971, the 3 governments signed an intention to proceed, ITP, document, at which point the aircraft was intended solely for the low-level strike mission, where it was viewed as a viable threat to Soviet defenses in that role. It was at this point that Britain's Chief of the Defense Staff announced, 2/3 of the fighting front line will be composed of this single, basic aircraft type. Prototypes and testing, edit. The first of 15 development aircraft, 9 prototypes, P01 to P09, and 6 pre-series, PS11 to PS16, flew on the 14th of August 1974 at Maching, Germany. The pilot, Paul Millet, described his experience. Aircraft handling was delightful. The actual flight went so smoothly that I did begin to wonder whether this was not yet another simulation. Flight testing led to the need for minor modifications. Airflow disturbances were corrected by reprofiling the engine intakes and the fuselage to minimize surging and buffeting at supersonic speeds. According to Jim Quinn, programmer of the Tornado development simulation software and engineer on the Tornado engine and engine controls. The prototype was safely capable of reaching supercruise, but the engines had severe safety issues at high altitude while trying to decelerate. At high altitude and low turbine speed, the compressor did not provide enough pressure to hold back the combustion pressure and would result in a violent vibration as the combustion pressure backfired into the intake. To avoid this effect, the engine controls would automatically increase the minimum idle setting as altitude increased, until at very high altitudes the idle setting was so high, however, that it was close to maximum dry thrust. This resulted in one of the test aircraft being stuck in a Mach 1.2 supercruise at high altitude and having to reduce speed by turning the aircraft, because the idle setting at that altitude was so high that the aircraft could not decelerate. The British Ministry of Supply assigned Chief Engineer Ted Talbot from the Concorde development team to provide intake design assistance to the Tornado development team in order to overcome these issues, which they hesitantly agreed to after noting that the Concorde intake data had apparently already been leaked to the Soviet Union. The German engineers working on the Tornado intake were unable to produce a functional Concorde-style intake despite having data from the Concorde team. To make the problem worse, their management team incorrectly filed a patent on the Concorde design, and then tried to sue the British engineers who had provided the design to them. The German lawyers realized that the British had provided the designs to the German team, and requested further information to help their engineers overcome the problems with the Tornado intake, but Chief Engineer Talbot refused. According to Talbot, the Concorde engineers had determined the issue with the Tornado intake was that the engine did not respond to unexpected changes in the intake position, and therefore the engine was running at the wrong setting for a given position of the intake ramps. This was because the Concorde had similar issues due to control pressure not being high enough to maintain proper angles of the intake ramps. Aerodynamic forces could force the intakes into the improper position, and so they should have the ability to control the engines if this occurs. The Tornado intake system did not allow for this. Due to the behavior of the German management team, the British engineers declined to share this information, and so the Tornado was not equipped with the more advanced intake design of the Concorde. Testing revealed that a nose wheel steering augmentation system, connecting with the yaw damper, was necessary to counteract the destabilizing effect produced by deploying the thrust reverser during the landing roll. From 1967 until 1984, Soviet KGB agents were provided details on the Tornado by the head of the West German Messerschmitt Bolkaublohm Planning Department, Manfred Roch. 2 prototypes were lost in accidents, both of which had been primarily caused by poor piloting decisions and errors leading to 2 ground collision incidents. A third Tornado prototype was seriously damaged by an incident involving pilot-induced pitch oscillation. During the type's development, aircraft designers of the era were beginning to incorporate features such as more sophisticated stability augmentation systems and autopilots. Aircraft such as the Tornado and the General Dynamics F-16 Fighting Falcon made use of these new technologies. Failure testing of the Tornado's triplex analog command and stability augmentation system, XAS, was conducted on a series of realistic flight control rigs. The variable sweep wings in combination with varying, and frequently very heavy, payloads complicated the clearance process. Production, edit. The contract for the Batch 1 aircraft was signed on the 29th of July, 1976. The first flight of a production aircraft was on the 10th of July, 1979 by ZA319 at BAE Wharton. The first aircraft were delivered to the RAF and German Air Force on the 5th and the 6th of June 1979 respectively. The first Italian Tornado was delivered on the 25th of September, 1981. On the 29th of January, 1981, the Trinational Tornado Training Establishment, TTTE, officially opened at RAF Cottesmore, remaining active in training pilots from all operating nations until the 31st of March, 1999. The 500th Tornado to be produced was delivered to West Germany on the 19th of December, 1987. Export customers were sought after West Germany withdrew its objections to exporting the aircraft. Saudi Arabia was the only export customer of the Tornado. The agreement to purchase the Tornado was part of the Al Yamama arms deal between British Aerospace and the Saudi government. Oman had committed to purchasing Tornadoes and the equipment to operate them for a total value of £250 million in the late 1980s, but cancelled the order in 1990 due to financial difficulties. During the 1970s, Australia considered joining the MRCA program to find a replacement for their aging Dassault Mirage 3s. Ultimately, the McDonnell Douglas F/A-18 Hornet was selected to meet the requirement. Canada similarly opted for the F/A-18 after considering the Tornado. Japan considered the Tornado in the 1980s, along with the F-16 and F/A-18, before selecting the Mitsubishi F2. In the 1990s, both Taiwan and South Korea expressed interest in acquiring a small number of Tornado ECR aircraft. In 2001, EADS proposed a Tornado ECR variant with a greater electronic warfare capability for Australia. Production came to an end in 1998, the last batch of aircraft produced going to the Royal Saudi Air Force, who had ordered a total of 96 IDs Tornadoes. In June 2011, it was announced that the Tornado fleet had flown collectively over 1 million flying hours. Aviation author John Lake noted that the Trinational Panavia Consortium produced just short of 1,000 Tornadoes, making it one of the most successful post-war bomber programs. In 2008, Air Force's Monthly said of the Tornado, for more than a quarter of a century, the most important military aircraft in Western Europe. Design, Edit. Overview, Edit. The Panavia Tornado is a multi-role, twin-engined aircraft designed to excel at low-level penetration of enemy defenses. The mission envisaged during the Cold War was the delivery of conventional and nuclear ordnance on the invading forces of the Warsaw Pact countries of Eastern Europe. This dictated several significant features of the design. Variable wing geometry allowed for minimal drag during the low-level dash towards a well-prepared enemy. Advanced navigation and flight computers, including the then innovative fly-by-wire system, greatly reduced the workload of the pilot during low-level flight and eased control of the aircraft. For long-range missions, the Tornado has a retractable refueling probe. As a multi-role aircraft, the Tornado is capable of undertaking more mission profiles than the anticipated strike mission. Various operators replaced multiple aircraft types with the Tornado as a common type. The use of dedicated single-role aircraft for specialist purposes such as battlefield reconnaissance, maritime patrol duties, or dedicated electronic countermeasures, ECM, were phased out either by standard Tornadoes or modified variants, such as the Tornado ECR. The most extensive modification from the base Tornado design was the Tornado ADV, which was stretched and armed with long-range anti-aircraft missiles to serve in the interceptor role. Tornado operators have undertaken various life extension and upgrade programs to keep their Tornado fleets as viable frontline aircraft. With these upgrades, it is projected that the Tornado shall be in service until 2025, more than 50 years after the first prototype took flight. Variable sweep wing, edit. Further information, variable sweep wing. In order for the Tornado to perform well as a low-level supersonic strike aircraft, it was considered necessary for it to possess good high-speed and low-speed flight characteristics. To achieve high-speed performance, a swept or delta wing is typically adopted, but these wing designs are inefficient at low speeds. To operate at both high and low speeds with great effectiveness, the Tornado uses a variable sweep wing. This approach had been adopted by earlier aircraft, such as the American Grumman F-14 Tomcat, which is the most similar in mission flexibility. The swing wing was also shared by the older American General Dynamics F-111 Aardvark strike fighter, and the Soviet Mikoyan-Gavik MiG-23 fighter. The smaller Tornado has many similarities with the F-111, however the Tornado differs in being a multi-role aircraft with more advanced onboard systems and avionics. The level of wing sweep, i.e. the angle of the wings in relation to the fuselage, can be altered in flight at the pilot's control. The variable wing can adopt any sweep angle between 25 degrees and 67 degrees, with a corresponding speed range for each angle. Some Tornado ADVs were outfitted with an automatic wing sweep system to reduce pilot workload. When the wings are swept back, the exposed wing area is lowered and drag is significantly decreased, which is conducive to performing high-speed low-level flight. The weapons pylons pivot with the angle of the variable sweep wings so that the stores point in the direction of flight and do not hinder any wing positions. In development, significant attention was given to the Tornado's short-field takeoff and landing, STOL, performance. Germany, in particular, encouraged this design aspect. For shorter takeoff and landing distances, the Tornado can sweep its wings forwards to the 25-degree position, and deploy its full-span flaps and leading-edge slats to allow the aircraft to fly at lower speeds. These features, in combination with the thrust reverser-equipped engines, give the Tornado excellent low-speed handling and landing characteristics. Avionics, edit. The Tornado features a tandem seat cockpit, crewed by a pilot and a navigator /weapons officer. Both electromechanical and electro-optical controls are used to fly the aircraft and manage its systems. An array of dials and switches are mounted on either side of a centrally placed CRT monitor, controlling the navigational, communications, and weapons control computers. BAE Systems developed the Tornado Advanced Radar Display Information System, TARDIS, a 32.5 cm, 12.8 in, multifunction display, to replace the rear cockpit's combined radar and projected map display. The RAF began installing TARDIS on the GR4 fleet in 2004. The primary flight controls of the Tornado are a fly-by-wire hybrid, consisting of an analog quadruplex command and stability augmentation system, CSAS, connected to a digital autopilot and flight director system, AFDS. In addition, a level of mechanical reversion capacity was retained to safeguard against potential failure. To enhance pilot awareness, artificial feel was built into the flight controls, such as the centrally located stick. Because the Tornado's variable wings enable the aircraft to drastically alter its flight envelope, the artificial responses adjust automatically to wing profile changes and other changes to flight attitude. As a large variety of munitions and stores can be outfitted, the resulting changes to the aircraft's flight dynamics are routinely compensated for by the flight stability system. A German Air Force Tornado undergoing maintenance in July 2004. The Tornado incorporates a combined navigation forward/attack Doppler radar that simultaneously scans for targets and conducts fully automated terrain following for low-level flight operations. Being able to conduct all-weather hands-off low-level flight was considered one of the core advantages of the Tornado. The Tornado ADV had a different radar system to other variants, designated AI.24 Fox Hunter, as it is designed for air defense operations. It was capable of tracking up to 20 targets at ranges of up to 160 kilometers, 100 mi. The Tornado was one of the earliest aircraft to be fitted with a digital data bus for data transmission. A Link 16'd its integration on the F3 variant enabled the exchange of radar and other sensory information with nearby friendly aircraft. Some Tornado variants carry different avionics and equipment, depending on their mission. The Tornado ECR operated by Germany and Italy is devoted to suppression of enemy air defenses, SEAD, missions. The Tornado ECR is equipped with an emitter locator system, ELS, to detect radar use. German ECRs have a Honeywell infrared imaging system for reconnaissance flights. RAF and ASIF Tornadoes have the laser range finder and marked target seekers, LRMTS, for targeting laser-guided munitions. In 1991, the RAF introduced TILD, allowing Tornado GR1s to laser designate their own targets. The GR1A and GR4A reconnaissance variants were equipped with TIRS, Tornado Infrared Reconnaissance System, consisting of one slow, sideways-looking infrared sensor on each side of the fuselage forward of the engine intakes to capture oblique images, and a single IRLS, infrared line scan, sensor mounted on the fuselage's underside to provide vertical images. TIRS recorded images on 6 SVHS videotapes. The newer Raptor reconnaissance pod replaced the built-in TIRS system. Armament and equipment, edit. The Tornado is cleared to carry the majority of air-launched weapons in the NATO inventory, including various unguided and laser-guided bombs, anti-ship and anti-radiation missiles, as well as specialized weapons such as anti-personnel mines and anti-runway munitions. To improve survivability in combat, the Tornado is equipped with onboard countermeasures, ranging from flare and chaff dispensers to electronic countermeasure pods that can be mounted under the wings. Underwing fuel tanks and a buddy store aerial refueling system that allows one Tornado to refuel another are available to extend the aircraft's range. In the decades since the Tornado's introduction, all of the Tornado operators have undertaken various upgrade and modification programs to allow new weapons to be used by their squadrons. Amongst the armaments that the Tornado has been adapted to deploy are the enhanced paveway and joint direct attack munition bombs, and modern cruise missiles such as the Taurus and Storm Shadow missiles. These upgrades have increased the Tornado's capabilities and combat accuracy. Precision weapons such as cruise missiles have replaced older munitions such as cluster bombs. Strike variants have a limited air-to-air capability with AIM-9 Sidewinder or AIM-132 SRAM air-to-air missiles, AAMs. The Tornado ADV was outfitted with beyond visual range AAMs such as the Skyflash and AIM-120 AMRAAM missiles. The Tornado is armed with two 27mm, 1.063 in, Mauser BK-27 revolver cannon internally mounted underneath the fuselage. The Tornado ADV was only armed with one cannon. When the RAF GR1 aircraft were converted to GR4, the FLIR sensor replaced the left-hand cannon, leaving only one. The GR1 reconnaissance variant gave up both its guns to make space for the sideways-looking infrared sensors. The Mauser BK-27 was developed specifically for the Tornado, but has since been used on several other European fighters, such as the Dassault Forward/Dornier Alpha Jet, Saab JAS-39 Gripen, and Eurofighter Typhoon. The Tornado is capable of delivering air-launched nuclear weapons. In 1979, Britain considered replacing its Polaris submarines with either the Trident submarines or the Tornado as the main bearer of its nuclear deterrent. Although the UK proceeded with Trident, several Tornado squadrons based in Germany were assigned to Caesar to deter a major Soviet offensive with both conventional and nuclear weapons, namely the W.177 nuclear bomb, which was retired in 1998. German and Italian Tornadoes are capable of delivering USB-61 nuclear bombs, which are made available through NATO.